Hello and welcome to all of you in a Study Mania channel. In this channel you will get all the educational services including the educational videos, trainings, seminars and all the technical videos. So for getting all these videos, please subscribe my channel and hit the bell icon to get the latest notification. Student, today we deal with the derivation of equation of motion by graphical method. So as you know, the three equation of motion is V is equals to U plus AT. Second is S is equals to UT plus half AT square. And third is V square is equals to U square plus 2AS. Where V is final velocity, U is initial velocity, A is acceleration, T is time and S is displacement. All these four parameters comes under these three equation of motion. So before starting the derivation of these three equations, we must have an idea of velocity time graph. What is VT graph? Before starting this derivation, you should know the concept of this graph. Let's say on y-axis we take the velocity v and on x-axis we take the time t. Let us take an assumption. If a body is moving from A to B with having constant acceleration, this is our assumption to derive all these three equations of motion. So what I am saying let us consider a body is moving from A to B with having a constant acceleration. Let us say this body is having an initial velocity, small u, and it reaches the final velocity, let's say small v. So on drawing the graph and completing the graph, let's say I draw a line in this way and in this way. We have a point, let's say this is C, this is D, this is E. So you can easily understand that in velocity time graph we have taken a constant acceleration and the slope of this line will give the value of acceleration. And if we consider the area under this line, will give the value of displacement. So the concept is the slope of the velocity time graph will give the value of acceleration and the area under the slope or a curve will give the value of the displacement. So with having these two concepts, we can proceed for the derivation of these three equations of motion. So now let's start with the very first equation of motion, that is V is equals to U plus AT. Proof. As I said earlier, the slope of the velocity time graph will give the value of acceleration. How you can calculate the value of slope? If I apply a simple mathematics, let's say this is angle theta. It is having a triangle, that is right angle triangle. So with having this right angle triangle, we can write tan theta by which we can calculate a slope. So by applying a simple mathematics, we can calculate the slope by tan theta, which gives the value of m. M is denoted as a slope, and which gives the value of acceleration. What is the formula of tan theta? That is perpendicular upon base. Perpendicular upon base. Good. So from the figure it is very clear. The perpendicular is BC and the base is AC. Okay. Good. Now just analyze the figure. In the graph, it seems that this BD is V, that is final velocity, and if I want to calculate the value BC, this is capital V minus small u, that is V minus U. Can you understand it? Okay. So by graph we can write in the place of BC is BD minus CD by AC. In the graph it is clearly shown that BD, you can write BD as V and you can write CD as U. and AC as, let's say, the time taken is small t from A to B. Okay, body is moving from A to B and it takes a time small t. So this is t. So while putting all these values, v minus u upon t, this is A. So while solving this equation on cross multiplication, you get v minus u is equals to at, or v is equals to u plus at. So here comes the first equation of motion. If I'm talking about the 9th standard grade, if the students are not aware about the trigonometric ratios, then also you can understand the concept, because you know the definition of acceleration. Acceleration is the change in velocity upon time taken. So this v minus u is the change in velocity and t is the time. So from that concept also you can derive it. So it is very clear if you don't know about the trigonometric ratios. So from the definition of the acceleration, you can easily derive this equation, that is change in velocity upon time taken. From here and here, the initial velocity is u, the final velocity is v. So the change in velocity is v minus u, and the time taken is t. So you can easily write this A is equals to BD minus CD upon AC. So by the definition, it is clear that acceleration is equals to change in velocity upon time taken. And if you are having a knowledge of trigonometric ratio, so you can calculate the tan theta, which gives the value of acceleration, which is the slope. Okay, now proceed for the second equation of motion. S is equals to ut plus half at square. Now, the second concept which I have discussed, what? The area under the slope, which kind of slope it is? AB. Good. The area under the slope AB gives the value of displacement. Gives the value of displacement. Good. Let us say if displacement is represented by S, then how can you calculate the value of displacement with the area? You can easily observe this is a right angle triangle, and the lower side this is a rectangle. So you can calculate the displacement as area of triangle. What is BCA plus area of rectangle? What is rectangle? ACDE. ACDE. What is the formula of triangle? Right angle triangle. Half into base into height. Okay. Half into base into height. And area of rectangle, length into breadth. Okay. So from the graph, you can write half into base. Base is what? AC. Good. And the height is what? BC. Length and breadth. The length you can write AC, and the breadth you can write easily AE. You can. Okay. So from the graph, it is clearly shown the AC is common. You can take BC plus A. And what you can write in the place of BC? In the place of BC, you can write half AC. BC is what? BC is BD minus CD plus A. As you see here, this CD and A is same. AE is equals to CD, which is U. You can easily understand with the graph, this AECD is same, that is initial velocity U. So you can write half AC BD minus, in the place of CD you can write AE plus AE. Okay, you can write BD minus AE plus AE. Okay, and here also you have taken the half AC, so you have to put here 2. Okay, you have to write 2 because you have taken the half common. So this 2 you should also include because half is not there. So AE, if you minus this AE from 2AE, what come? Half AC BD plus AE. Okay. So from the graph, it is clearly seen that in the place of AC, what you can write? In the place of AC, you can write T. In the place of BD, in the place of BD, you can write V. in the place of AE, you can write U. So on putting all these values in this equation, what do you get? What you get? S is equals to half. In the place of AC, you can write T. So in the place of AC, you can write T. In the place of BD, you can write V. In the place of AE, you can write U. Okay? So on solving these equation, what do you get? You get here BD minus AE plus 2AE means BD plus AE. A you can write U. In the place of BD, you can write V, and this is T. Using first equation of motion. On using equation 1, you can write V is equals to U plus AT. So put the value of V here. What you get? S is equals to T U plus AT plus U. Now this U and this U will add up and will give half T 2U plus AT. And if you multiply this half, what you get? 2 cancel means UT plus half AT square. In this way, you get the value of displacement, the second equation of motion, that is S is equals to UT plus half AT square. Similarly, you can apply here, as I write BC here, BC, you can easily write here V minus U in the previous step while calculating. And if you go through the graphical method, you can do like that. And in this way, you will get the derivation of the second equation of motion. Now proceed for the third equation of motion, that is V squared is equals to U squared plus 2AS. What is the proof of this? It is very easy one. Using first equation of motion. I am using the first equation of motion. How? Let's see. The first equation of motion, we know V is equals to U plus AT. Okay? So from here we can write AT is equals to V minus U, or T is equals to V minus U by A. We can write. Okay? Now on putting the value of this T in equation 2. What is the equation 2 is? S is equals to UT plus half AT square. So S is equals to UT plus half AT square. You have to put the value of T here and here. So what come? U V minus U by A plus half A V minus U by A whole square. So you can easily, once that V minus U by A is common, so you can write V minus U by A and bracket U plus half A multiplied means it is a square, so 1 is left. This A and A is cancelled out, so what get? V minus U by A, this is U plus, if I take the LCM 2, then this is 2U plus V minus U. You can write V minus U by A. 2U minus U is U plus V by 2. You can easily see this is A minus B and A plus B formula. So you know A minus B and A plus B is equals to A square minus B square. So applying this formula, you can write V square minus U square upon 2A, and here is S. So on cross multiplying, you get V square minus U square is equals to 2S, or V square is equals to U square plus 2S. So this is the third equation of motion. So we can easily derive the first, second and third equation of motion. Let's solve. Thank you so much. If you like our videos, Please subscribe the channel and hit the bell icon to receive the latest notifications.